All right, well, welcome back to the video lectures here, continuing today with section 1.5, which, as you know, we'll be talking about how to prove an argument is invalid using the counterexample method. So I hope, obviously, you can see that we will be talking about deductive arguments, since deductive arguments are the ones that are either valid or invalid. Before we actually get into this counterexample method, though, the specific technique, I want to talk to you about argument forms. These are features of deductive arguments in particular that you might have noticed already in the class, but if not, I want to make that absolutely clear here. So, to illustrate what I'm talking about here, we will look at a couple of examples of deductive arguments. Now here, I hope you would be able to recognize that since each of these claims in this argument, right, starts with the word all collies are dogs, all dogs are mammals, and then again, all collies are mammals here. Whenever you have an argument whereby, I should say, each of the claims begins with the words all, no, or some in that argument, then you know that you're dealing with a categorical syllogism, right? So that's something you looked at in 1.3, but it's worth remembering here. So we're looking at a categorical syllogism here. And what we can notice is that this argument has a particular structure to it. Now, that's what we'll be looking at here as we proceed. Before we do, though, let's throw out another quick example here. This one, as you can see, a key word in this one is the word if. So when we say, if the bus is running, I can get to work, so I can get to work because the bus is running, again, this is a deductive argument, and most specifically because one of the premises here, this first one, is a conditional statement, right? It's an if-then statement. And anytime you have an argument where at least one of your premises is a conditional statement, we call that a hypothetical syllogism, as you know, again from 1.3, and it's deductive. So what we're going to be able to look at here, and why I actually wanted to have you look at sections 3.1 and 3.2 before you look at 1.5, is because they are especially going to help us with these kinds of categorical syllogisms. So I'm hoping now you can recognize that among these three individual statements within the categorical syllogism, you can find the quantifier, for example. So in the first one there, it's all. And then the subject term is collies. Copula is are. And then the predicate term is dogs, right? So with that knowledge, and then you can continue on with the other two claims there, with that knowledge, I'm hoping you can come up with this as an argument form, right? So what we see here is that it says that all C, and of course C there is standing for collies, the subject term, RD for dogs, the predicate term. Second premise we get would be all D are M, and thus all C are M, and you're just drawing that from this original example here. So I'm hoping that, you know, even based on just a little bit of background here in determining whether or not arguments are valid or invalid, you could see that this first argument here is clearly invalid, right? In other words, just to run through this, in other words, if it were true that all collies are dogs, and it were true that all dogs are mammals, it would have to be guaranteed then that all collies are mammals. Not only that, in fact, in this one in particular, we could go past that level of evaluation and see that not only is it valid, but since it is true that all collies are dogs, and it's true that all dogs are mammals, this is not only valid, but sound. In the second example here, take the argument form in just a second, but in the second example, again, we can evaluate it for validity. If it were true that if the bus is running, I can get to work, that, in other words, that somehow there's this magically secure connection between the buses running and your ability to get to work, and it were also true that, here's the last premise at the end, that the bus is running, it would in fact be guaranteed that I can get to work. So that is also valid. However, in the second case here, I think, at least in most scenarios I can think of, while it would be valid, it would not be sound. In other words, it's not usually true, I think, in any real-world example that if the bus is running, I can get to work, because we know that the bus might be running, but perhaps there's a collision blocking traffic, or maybe you're sick, so you can't get to work for that reason. So it's not actually true in reality, which would mean it would be valid but unsound. All right. So taking the argument form, though, of the second example, You can see it turns out to be if B, then W. So W because B. Now, since we're dealing with a hypothetical syllogism here in the second example, you can hopefully recognize that the B here stands for the entire antecedent, right? We introduced that term antecedent before. And then the W here stands for the entire consequent I can get to work, right? So just to remind you of those terms in case you forget them. If antecedent then consequent. I mean, that's sort of the pattern here, right? So we know these terms from before. Now, just to be clear, when we're dealing with, and this is an important point, when we're dealing with a hypothetical syllogism, we need to understand that the B and the W here don't stand for types of things as the capital letters in the categorical syllogism above stand for types of things, right? Because we're not dealing with categorical logic in the second case, we're dealing with hypothetical logic, if you like. So in other words, just so we know, the B here does not stand for bus, the W does not stand for work, right? This is not what I like to call Neanderthal logic. We're not saying if bus, then work, right? That doesn't work here, doesn't make sense. So it says, B then, in other words, says the bus is running, and W is capturing I can get to work. Now, what I want to tell you here, what I want to make clear, is that these arguments, right, they are valid or invalid not because of the content here, not because we're talking about dogs and mammals and collies or buses and work and so forth. They are valid or invalid by virtue of their structure, by virtue of their form. As I'm just saying here. So I will illustrate that point. Actually, I'll go ahead and back it up and illustrate that point here, right? So let's say that we let C, you know what, I'm going to go ahead and erase this. I'll have a little bit more room. No, you know what I'll do? Sorry, I'm just experimenting with this. Bear with me here. There we go. So we can see that a little better. So we have all C or D, all D or M, all C or M, just to replicate what we saw in the PowerPoint slide there. And again, I've just said that this argument in particular is valid, not because it's talking about collies, dogs, and mammals, but it's valid because of the structure. And what that means is that I could come up with any random C, D, and M, and plug something into those terms, and the argument would still be valid. So, for example, you don't have to choose anything that begins with the letter C, of course. We could say C stands for birds. And then we can pick something entirely different, something completely random, we might say. We can say soccer balls, for example. And then finally here we plug something else in for M. Birthday cakes, for example. Very random things. But plug it into this structure and you will see that it is still going to be valid, because what we're going to end up with is all birds are soccer balls. So let's assume that somehow that's true, that all birds are soccer balls. Let's assume it's also true then that all soccer balls are birthday cakes. If both of those things were true, it would in fact be guaranteed that all birds are birthday cakes, right? So we know that it's the structure that makes it valid. Now, of course, soundness has gone away, right? The structure will not preserve soundness. If we plug in random things like this, we don't actually have in reality true premises followed by true premises guaranteeing a true conclusion. But validity is preserved by the structure. Now, we'll also then work on the hypothetical syllogism here. And so that said, I think I got it off there a little bit. So let me just fix that so you can see it better. There we go. We can barely see that, but it might work well enough. If B, then W, B, therefore W. That's what this line indicates. Separates the premises from the conclusion. So, again, I'm telling you this is a valid argument form. If B could stand for any claim at all, and W could stand for any claim at all, and it would still be a valid argument, is my point. So B could stand for day is Monday, for example. W could stand for the Earth is round. We plug these back in. I know you can't see me here, but just I'm still here, don't worry. If today is Monday, then the Earth is round. If that somehow were true, and we assume that it's somehow true that today is Monday, then wouldn't it be guaranteed that the Earth is round? So once again, this would be a valid argument. And that's what I want to get, the point I want to get across. That what makes these arguments valid is not the content, because this is crazy content in both cases here, but it is the fact that they have a particular structure, and these are recognized as valid argument forms.